Hello everyone, I'm Xiao Gang. In this section, we'll mainly work on capturing pixels in UE5. Let's open the editor. You can see we have a high relation shrink here with some parameters. We'll ignore them. Click Capture. After clicking Capture, you'll notice there's actually a screenshot here, right? And the resolution it captured is this resolution, as you can see. Okay, sometimes we're not satisfied with this resolution. We can do this. We use this. We use one for this. Okay, another image was generated here. You can see this image looks like this, and its resolution is like this, right? Maybe we're not very satisfied with this either. We can do this. For example, let's give it a double resolution. Give it a double resolution. Then let's take a look at this image. Okay. You see, it should be like this image. You can see its resolution has doubled. And sometimes we want to give it a 1K resolution, right? We can do it this way. Normally it's 1080, right? Okay. And then let's look at this image again. This image, you can see its resolution. So it's called 1920 times 1080. 10, 10, 1, 1080. Okay, so actually sometimes the reason for explaining this is because the engine, it sometimes mentions many tools to us, like screen recording or screenshot or audio and such things. It actually has certain tools and modules for all of these. These are all hidden quite deep and need everyone to discover. Then here, we will also use the engine's interface to obtain this pixel paper. And I remember there is an interface that can only be used in the editor. And if we use this interface, you can be more at ease, because this interface of ours, it can run after being packaged. This manual only verification is fine. Okay, so understand what this section is about. So here we will create a subsystem to do it. Why do we need to create a subsystem here? Because when we talked about multi-threading earlier, you can know that rendering, for example, lags behind the main thread by 1 FViewport. After you issue the rendering command, you have to wait until the next frame to actually get the results. And it is an asynchronous situation. Then we can see here, let's change its name. This is called VVP. I'll call it one short. This way we can keep it simple. One short subsystem. Then we directly change its name. Find it and then here, let's confirm first. Make sure our compilation definitely passes. Because if the compilation fails, it will be especially troublesome to troubleshoot this issue later. This is an external dependency image. This can be turned off through some settings. Putting it here is a bit redundant. Okay, as for this underlying part, let's not look at it for now. Then, after we have a subsystem here, we need to create a subsystem. So obviously, let's just copy one. Since we've written so much code here, it's just for you to paste. If you don't write it by hand yourself, how should I put it? This is something you need to do on your own. Write more of it, after I've written it so many times. Actually, I still prefer to just paste it over. That way, it's less error prone. We don't need this public or ticket. Paste it over like this. Obviously, we're missing something at the end here. After pasting it like this, we need to press Ctrl Shift plus U here. Okay. This doesn't seem right. Let's take a look. The reason it's not quite right is because we haven't changed this name. Let's go back to where we were, because this name of ours comes from the name. So we need to change this part. Let's fill in the reflection file for this part. Okay, then let's confirm again. Creating it this way should be fine. Then let's change this to true. Okay, here, we'll give it a super. We'll do the single one first. Then we'll do the multi-image one. Because the multi-image case is clearly much more complicated. We are here. Okay, let's compile it now, because it seems there was a problem when we created it earlier. I'm worried it might affect the code written before. Okay, after confirming there are no issues here, what do we need to do next? We are mainly using this struct. Let me show you what we are using. Let's put it here first. Let's paste it over first. We are using this one. What is this struct? It is in FViewport. And where is its location? It is inside UI client. Only the client has crest this kind of thing, and its location is under this ngin. See? ngin public. Then go further down, there is a UI client here. And then you can take a screenshot here. And here, it shows whether to display UI or something. And here are several interfaces. Actually, the engine has written a test class called screenshot. We can do it like this. You can take a look at how it is written. You can see this automation. Hey, after you see this thing, are you starting to get an idea? Util automation automated testing. Of course, this place is related to this screenshot, right? You can see. And then you can simply take a look at this code. Take a look. Then you can see this grant. This is also related to automated testing integration. This is related to Niagara. This is the shader comparison place. And this is the developer tools. You can see it here in this place. If your version is different, some things might not be available. But it doesn't matter. Just follow what we've explained. This place must be a screenshot-like task. After taking the screenshot, it uses this proxy method to obtain the pixel data. Actually, this code is just for demonstration. This is Edu client. This is our client socket. Right. This is gamer client. Actually, there are many such example codes. Okay, we'll stop the demonstration here. Not stop the demonstration here. We'll just explain this thing. We mainly used this struct. This struct helps us implement the screenshot functionality. It is done through this proxy method. Well, now let's go back to our place, and delete this part. Obviously, we need to take a screenshot, right? So we need to do this binding work. Okay, if we start writing here, first this place is a bit messy. Let's write first, talk first, then write. Then I'll explain it to you. Because within this set of logic, we can only then do melt it. Said, because this thing is too convoluted. Okay, so let's declare a delegate here. This delegate is called a delegate with only one parameter, and we call it WebP generation result callback. Result generation callback. Okay, so after we generate this proxy, we need to instantiate it here. As for the name, let's see what name is appropriate for this name. We'll just call it. Let's change the name. Let's protect this proxy. And for this proxy, we'll call it simple web appline short callback. That's the name. Starts with RF. Then this P should be capitalized. Because it's an abbreviation for picture, we need to discuss this issue. Then after this proxy, then when we initialize, we need to bind this method. This is mainly to allow us to access the execution of this proxy called WebP. Such a result, we directly bind your object. Actually, binding you function would also work. Let's bind you function. This way, we can write a bit less. Then for the name of this method, let's call it method. So in this way, we bind a method. Okay, once we have this method, what do we need to do? Now, let's create this method. This method is a protected method. We don't need external access to use this method. It is only allowed to be used within our internal workflow. Of course, this class does not have the derivative macro either. This class does not have the derivative macro because we don't want users to directly use this class. Okay. When it executes, it will trigger this callback. Then it will tell us whether the callback result of this image generation was successful or failed. Okay. Then next we are going to define a method to start our screenshot. For this method, we can actually make it public. We'll just call it one shot. Simple one shot. Begin. We'll call it begin. Okay, we start this process. But we still need to do some flow control here. But we won't do it inside this, because that would conflict with the later stuff. Just simply test this thing. So what we need to do, first we need to trigger this command. Let it execute all fresh round comments first. Execute everything. You can see this command is under threes. So if you drop it here, you'll find that it probably won't compile. I think normally it won't compile because it doesn't know what this is. Obviously, we comment it out here, then it will compile successfully. Yes, okay. So how do we solve this problem? Then go into our build.cs. We just need to add this render core in. We put it here. Put it inside the bright. Actually, here, where to put it can also be a bit particular. Or not particular at all. It depends on whether this module above needs to be imported into that project. If you place it above, it means your project uses this module, and it will be imported as a dependency. You can see that we have already compiled successfully here. So here we have essentially synchronized all of this. Then we directly bind this delegate. We bind it here. So what is this thing? It gets the game world port collect earlier, and then executes the. When this screenshot is executed, it triggers this delegate, then bind this object. We bind this object to this string code, the method bound to it, and this thing will return a thing like a delic handle. We need a delic handle because this is one-time use. That is, once you finish the settlement, we don't want this thing after I register it to cause a screenshot, to take more than 10 screenshots. That is, to trigger more than 10 of these screenshots, callback type of thing. So that's why we need to record it. This delegate is the same kind of thing as our timer handle. And then the screen callback is a very important method. So we can add it here. Let's still generate it with ufunc. This is when we talked about delegates. So what does its function signature look like? Its function signature looks like this. Then looking at this function signature, you will know it is clearly for the width and height of the resulting pixels. And then the actual data of the entire pixel is like this. Then after we bind this delegate, you can see the signature. You can see it is here in this. So this means when a screenshot is taken, a delegate of this type, once you bind it, it will trigger. So when it triggers, what work do we need to do? When it triggers, we need to execute it asynchronously. Yes, for this asynchronous execution, we will definitely need to request an asynchronous thread here. Right. Okay, let's write this asynchronous thread here first. Okay, as for this data, we will have it all copied. We will have it all perform a direct copy here. Then we can directly remove this interface. Our interface is set up here. Still remember, that's it. This is the interface. We remove this interface here. We need to include this header file here. Let me think. This header file should look like this. Okay. Actually, let me emphasize again. If you write it this way, packaging the project is fine, but packaging the plugin will cause issues. So how do we handle this packaging clock issue? You need to take all the things you use, include all of them. That is, you need to write this. Otherwise, this place will burst out. It can't find this thing. When you package it, it will prompt that there is no problem here either. And this place generates a static image. We just pass this mnemonic into it. This is missing a parenthesis. Here, let's check if these parameters are correct. Obviously, the parameters here are not fully passed. We also have this inequality factor. Let's set it to 100. Okay, let's check again. Obviously, this place requires a picture path. As for this path, we can actually hard-code it for now. Here, harder. It is also fine. Let's hard-code it for now. We directly pass. Later, we won't hard-code it because this is the fastest. We get the path of our current project served from GapSave. Okay, then after that, we concatenate one. Concatenate one. We'll use it every time. Still do it this way. Extreme. Fails them. Fail them. Then let's use a GUID here. Use a GUID. Then let it tutrun. After tutrun, we let it add this one shot. Add this one shot. Then finally we splice together a web. Then splice this path into it like this. Picture P. This is the path we want to save. Okay, here, let's put the first one. Okay, this place still hasn't passed. Let's see what the reason is. The reason is that this is written like this. This is Viewport, this is Viewport. So we need to construct a Viewport. We take this place here. We give it a Viewport. P size. Let's make it simpler. Let's set the y of p size. X equals this in white. Then the y of this p size equals this. After writing it like this, we just put this p size here. Let's take another look at this interface. Look at this part here. The reason it hasn't been given is what? The reason it hasn't been given enough is because we didn't add const here. Didn't add const. I think writing it this way is not good. Let's not let it take the address. Let's just let it hold a copy. Here we added a const. Actually, adding const here is completely fine because we don't intend to modify this. Modify this data. We are just using it. We use a reference here. Mainly to save space. Right, give it an alias. Okay. Here we can see this in quick chair press. It has, because it is a constant, so here we can add a const. So this place also needs to be changed. Declare this method as const. Change this to a const. Remove this part. Then we remove the const here. Put it here. After doing that, it should be able to compile successfully. Okay, no problem. We have handled this cont issue here. Let's go back to our subsystem. Actually, at this point, we can, in this asynchronous thread, we have actually completed the generation of the web. But here we are not sure whether the generation result succeeded or failed, right? But we need to notify the main thread of this result. So we need to copy this delegate like this. Copy it like this. And actually, we can also obtain our subsystem this way. Let me think about it. We obtain the subsystem here. Let's capture this pointer. Then we directly execute this here. WebP, this failish extract come back. Here, we can directly let it. Bound should be exact if bound. Okay, so after executing it like this, anyway, when you use this pointer, you must be very, very careful. Okay, then this execution will jump to this place. That is whether this side succeeded or failed. Okay, if we succeed, right, then we have succeeded. Then we generate this image. If we fail, then we need to handle the reason or information for the failure. This part of ours does not expose the reason or information for the failure, right? So we need to expose it. So how do we do it? In this part, we need to declare a delegate. This delegate is specifically used for this. To reflect to the blueprint, we can put it here. Reflect the generation result to the blueprint. Reflect the generation result callback to the blueprint. Because this callback is mainly for the blueprint to use, right? Okay, here we just need to execute it. Actually, we should print this information for both success and failure. Not printing this way. We'll just let it execute directly like this. We haven't instantiated it yet. Let's instantiate it. Put it here. Okay, so after we instantiate it, we can execute it right here. And this should be exact if found. Well, obviously, this is a single wave, right? How do we go about handling it? Then we need to change this begin stand here. We need to pass a parameter here called encoding. Then we need to paste it here. Then we put it here. After doing this, we need to copy the incoming delegate here. Copy it like this, not equal to it. Okay, that's fine. Then after we copy it in screenshot, when this thing is done, it will come here. Then we need to perform work here. If we give a boolean, if we are working, when we call this, when we are working, we won't let it execute. If it is already working, we can just let it return. We just let it. We let it pass in this delegate. Directly give it an exact false. We didn't provide any return information. Actually, we could provide some return information. We didn't write it. Here we just return. And here, now that it comes in, it must be wrong. How about giving a true? Okay. And here, note the execution at this point. We cannot execute here. We need to jump back to the main thread for execution. So this way we are crossing frames. Okay, then we put it here. Put it here. Capture of this. Obviously, we need to capture this result as well. Okay, then after jumping back to the main thread, this is the result of our main thread execution. then jump back to the main thread. That means jumping back to this point. Actually, we have already finished generating it this way. Then we can proceed with the next generation. So we'll just change be working to a this first execution is complete. Then after the execution is complete, we need to perform actually we need to do this cleanup operation on this agent. So let's first check whether this thing is available. Right. Actually, like this. Then we'll just remove the spin capture. Actually, here. We'll just remove it directly here. Yes, directly. We put this by working here. Put it here. Yeah. It doesn't seem very suitable to put it here either. Let's control the process again. We let it execute and put it here. Okay. Then here, post positioning. Then we cancel this proxy. So let's put this cancellation a bit earlier. When it executes, we cancel it because when it executes the callback, we have already executed it. We don't need it to execute anymore. So we clear it here. Okay, good. So we have finished this feature. Let's test it next. Let's check where the leak is. Obviously, it's leaking here. Okay, then let's run a few tests. After the test, we'll go over the process again for everyone, because it might be a bit much. This thing is a bit difficult. Please don't hesitate to like, subscribe, share, and tip to support Mingjing and Diandian.